So today we're going to review a little bit. You learned about slope in algebra, but now we're going to again kind of review how to calculate slope and then determine how to use slope to help us determine if lines are parallel and perpendicular. So first let's again define slope. So basically it's a rise over a run. So it is the ratio of the vertical change, so the vertical change of a line, and basically the vertical change is referred to as the rise, so that's where we get its rise over run. So it's the ratio of the vertical change to the horizontal change. And basically the horizontal change is referred to as the run. So a lot of times you hear us talk about like slope is the rise over the run. That's where it comes from. Rise vertical, run horizontal. In ratio, again, don't get scared for the word ratio. That basically just means it's a fraction. Like you're putting, the vertical change on top, then the horizontal change on the bottom. The slope formula, which always can be found on your star chart, is, so here is, all right, the change vertically, so that's the rise, so you're figuring out the difference from one y to the other, so y2 minus y1 over x2 minus x1, so that's the slope formula. Like I said, you always have it on your star chart. And remember, these x's and y's are coming from any ordered pair. So if we had these ordered pairs in 2, 3, and then we had another one in 5, 6, well, this is always x1 and y1, and this will be x2 and y2. So that's where you're getting your x's and y's. They're actually points on the coordinate plane. Now, slopes of lines in the coordinate plane, they can be negative, positive, undefined, or zero. So if you have a negative slope, what's going to happen is we read this graph here, okay, from like left to right. So basically, when you're reading from left to right and you see this line here, it's going down. When you go down like this, from left to right, that's going to be called a negative slope. So basically, when it falls from left to right, you're going to get a negative slope, and you can see that there in that line J. All right, a positive slope is when it is going to rise from left to right. So this is going to be a positive slope line. It's going to rise. So it's rising up from left to right. These other special cases, these are certain lines, so undefined slope is when you have a vertical line. So like in line N right here, you see that that is a vertical line. So vertical lines have a undefined slope. And we always use the little silly story about pretend like you're skiing and you come to this slope right here, and what would happen if you were to ski down this slope? You would become undefined because you would go flat and hit the bottom. So if it's a vertical line, you're undefined slope. And then we have one more, which is zero slope, and that's here in our line L. All right, any horizontal line is going to have a zero slope. So if you're skiing along this slope here, think about if you're trying to ski through something that is this flat. I don't know if you've ever skied or not, but it is not fun to try to pick up your skis and go through the snow on a flat surface. So horizontal slope, this is zero fun. It has zero slope. So now let's look at example 1, and we're going to find the slope of line A and of line C. So to find the slope of line A, again, we're going to use the slope formula. So we always want to start off with the formula. So slope is y2 minus y1 over x2 minus x1. So let's look at line A. We'll say this is for line A. And so here are the ordered pairs right here and right here for line A. Now they're already giving us the ordered pairs, which is great. You can also like pick other ones if you want to, as long as they're going perfectly through the graph. You have to pick pretty points that are going perfectly through. So we have, there's our ordered pairs, and we can write them out here so we don't get them mixed up. 4, 6, 0, 2. So there is, again, here's x1 and y1, x2, y2. So let's calculate the slope. y2 is 2 minus y1 is 6 over x2 minus x1. So 2 minus 6 is -4. 0 minus -4 is, 0 minus 4 is -4. Slope is always reduced to the most simplest form. So in your calculator, if you need to do this in your calculator, you hit -4 divided by -4, and it's going to reduce it for you in a fraction, and that is basically two negatives are going to make a positive, and that reduces to 1 over 1, or you could simply just say that the slope is 1. Because remember, any whole number can be put over 1. It's just kind of like imaginary. We don't always write it, though. So basically, you have a slope of 1. All right, line C, again, the slope formula, y2 minus y1 over x2 minus x1. And they've given us our ordered pairs here in 0, 6 and 4, 6. So we have, 0, 6 and 4, 6, we have y2 minus y1 over x2 minus x1. So 6 minus 6 is 0. 4 minus 0 is 4. So basically what happens here is you have the 0 on top, and you can put this in your calculator, 0 divided by 4, and what's going to happen is you're going to come out with a 0. Because you can see here our line C, right, is a horizontal line. Remember, horizontal lines are no fun. They have 0 slope. Another way you can identify lines that are going to have 0 slope is just, let's look at the ordered pairs. So if we look at these ordered pairs here, you should kind of notice something here about the y's. They have the same y. So anytime you have the same y, this line is going to be graphed where y is right here at 6. So you see this line is going across here right at 6. So you have two y's that are the same. It's going to be a horizontal line. Slope is 0. Now why don't you try to find the slope of line B up here in the picture. So here's line B, and of line D, which is this line right here. So you try to find those and then come back and we'll check it. All right, let's see what you got for line B. So here again is line B right here, and again we can see it there. And we are given 2 good points on line B, this one at 4, 6 and this one at 7, 3. So we always want to start with the slope formula, y2 minus y1 over x2 minus x1, and our ordered pairs are 4, 6. I'm just going to kind of write them down here. 4, 6 and 7, 3. So remember, that's our x1 and y1 and x2 and y2. So if we plug that in, we would have 3 minus 6 all over 7 minus 4. So 3 minus 6 is -3. 7 minus 4 is 3. And we always reduce this to the most simplest form, and that will reduce to -1 over 1. Or again, you can just write it as -1. And we can also double check that, because remember, slope is rise over run. So if we go to our graph, we can go up 1, backwards 1, up 1, backwards 1. So the slope is back 1, up 1. All right, and so hopefully you got this for your slope of line B. Line D, so this is line D right here, this one, and it is a vertical line. So if you remember from when we started off, vertical lines have an undefined slope. So right away, once you notice that this is a vertical line, then all you have to write is that the slope is undefined. Now, if you don't recognize that, okay, you can still use some points there. See, one of the ordered pairs is 4, 6. That's right there on D. And we have another one right there in 4, 0. So again, let's kind of look at, notice what those x values are. When you have the same x value, that means that that line is going through where x is 4, right here. It's going through that point and it's drawing a vertical line. So you can see how you get an undefined slope when you put it in the formula. We have 0 minus 6 over 4 minus 4. So that's going to give us a negative 6 over 0. You cannot divide anything by 0. So think about if you're trying to divide a pizza into 0 pieces. That's just not feasible. So when you put this into your calculator, you get an error. When you get an error out of your calculator, what that means is that that slope is undefined. So vertical lines have an undefined slope, horizontal lines have a slope of 0. Now, what we really want to get into are the slopes of parallel and perpendicular lines. So you can see over here in the diagram, you have 2 parallel lines. Well, what is special about the parallel lines is that they have the same exact slope. So in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. So basically, we are going to be able to use the slope formula to tell if lines are parallel or not. So remember, you just can't look at lines and tell, and what if the little arrows aren't there? Well, now we're going to be able to ensure that they're parallel, perpendicular, or neither by finding the slope. Now, perpendicular lines. So you can see here we have 2 perpendicular lines. So in a coordinate plane, 2 non-vertical lines are perpendicular if and only if their slope is, all right, -1. So basically what that means is that you have, if the product of the 2 numbers is -1, then the numbers are called opposite reciprocals. Let me give you an example because I know that's a little confusing. But if I have a slope of 2/3, the opposite reciprocal, and I always say this is called flip the number and flip the sign. So the reciprocal part is where you're flipping a fraction upside down, and the opposite part is where you're changing the sign. So make sure it's opposite reciprocal, because if it's positive, then it's going to become negative. So the perpendicular slope here, since this is positive, my perpendicular slope is going to be negative. Then so that's the opposite part. Now I have to reciprocate. So I have to flip this fraction upside down, and it would be 3/2. So this is when you have perpendicular lines. This is what the slopes are going to look like. Like one line will have a slope of 2/3, and if it's perpendicular, the other line will have a slope of -3/2. So that's where this whole, the product of their slope is -1 comes from. If you were to multiply these 2 fractions, and we would have 2/3 times -3/2, and we were to multiply that. When you multiply fractions, you multiply across. So this is -6/6. The outcome is -1. So anytime you get a product of slopes that is -1, then the lines are perpendicular. So now what we're going to do is find the slope of each line and decide which lines are parallel, if any of them. So we have 3 lines here. We have line K, all right, K1, we have K2, and we have K3. So we're going to find the slope of those lines. They give us our ordered pairs, so remember we're going to use the slope formula. It doesn't matter which one is 1 and which one's 2, x1, y1, x2, y2. So let's do the slope formula. And remember, if you need it again, it's always on the star chart, and we can write it up here. So y2 minus y1 over x2 minus x1. All right, so let's plug these in. So we have y2 minus y1 over x2 minus x1. So on these, and I know we've talked about this before, you've got to be careful with these double negatives because that makes one big new positive. So this is actually negative 6 plus 1, which is negative 5, negative 4 plus 3, which is negative 1. Again, you always want to reduce this, so put this in your calculator if you have to. Negative 5 divided by negative 1. The outcome, 2 negatives make a positive. So this is just 5, or remember you can say it's 5 over 1. So this is K1. So now we have to find the slopes of the other lines. So K2. Alright, so we have y2 minus y1 over x2 minus x1. So this is going to be a negative 6 over negative 1. Again, two negatives make a positive. This is 6, or 6 over 1, same thing. Now let's try line K3. So we have y2 minus y1 over x2 minus x1. So negative 3 minus 2 is negative 5. This is going to be negative 1. Two negatives make a positive. So here's the slope of K3. K1, and K2. So the question again is which lines are parallel? Well, parallel lines have the same exact slope. So what you do is compare the slopes. Now look what happens. Here we have a slope of 5, here we have a slope of 5, here we have a slope of 6. So because K1 and K3 have the same slope, then they are indeed parallel. All right, the slope of K2 is different. So K2 is not parallel to the other two lines. Now, see if you can do the same thing in the checkpoint 3. It's telling you that you have a line C that passes through to negative 2 and 5, 7, and line D passes through these 2 points. Are the lines parallel? Explain how you know. So basically what you're going to do, it's the same thing as what we just did up here. It's just that you don't have this diagram here. But you still have the points, so you need to find the slope of each line and then compare it. And come back and check your answer. Okay, so for your slopes, you should have got the first line C passes through these points. It has a slope of 3. This has a slope of negative 3. Again, you got to be very careful with the double negatives, and you always have to reduce here into a fraction. So 9 divided by 3 is 3. Here again, we had 2 negatives. Be careful here. This is negative 12 divided by 4. You cannot forget that negative, and this is going to be negative 3. So they are not parallel. So now we're going to talk about perpendicular lines. Now remember what we said about perpendicular lines is that they have slopes that are opposite reciprocals of one another. So you have to flip the number, flip the sign. Line H passes through these 2 points. They want us to graph the line perpendicular to this one that passes through the point 2, 5. So first let's plot these points. We have over 1 down 2 and then 5, 6. Okay, so there is our line. Now, what we want to do, and it tells you right here in step 1, is that first thing we need to do is to actually find the slope of this line first through these points. So let's do that. All right, so we're going to do y2 minus y1 over x2 minus x1. So again, we have double negatives. So this becomes 8 over 5 minus 1 is 4. 8 divided by 4 is 2. And remember, we can always put this over 1. All whole numbers can always be put over 1. And that helps because, remember, we have to flip the number, flip the sign. So now, we have a slope in this line that we just graphed of 2 over 1. We have to come in and draw a line that's perpendicular to it. So it's going to come somewhere through here. You can't just eyeball it and throw some random line up there. You actually have to graph the line based off of the slope. So since the slopes are opposite reciprocals, you know that whatever you multiply this by, it has to get you a -1 in the outcome. So basically, if this is your slope, 2 over 1, your perpendicular slope, you're going to flip the number and you're going to change the sign. So to have a perpendicular slope, you're flipping the sign. So flip the sign, flip the number. So this fraction gets turned upside down, and since this one is a positive, this one has to be a negative. These are opposite reciprocals. Change the number, flip the sign. So now you can see that if you put this in as 2 over 1, then what has to go in here to get you a -1 is -1/2. Because, well, look, we can check it. 2 over 1 times -1 over 2. -2 over 2, yes, that reduces to -1. So anytime you have a slope of -1, a product of the slopes of -1, the lines are perpendicular. Now we're going to use the rise and the run to graph the line. So basically what you do, it's telling you you have to go through this point. So again, we have this line H. The question is, the instructions are to graph the line perpendicular to this one going through this specific point. So we next need to graph that on the graph. So over 2, up 1, 2, 3, 4, 5. So through that point, we must use this point. And since it has to be exactly perpendicular to it, the only way we can ensure that is by counting out this slope right here, because this is the perpendicular slope. So from this point, you're now going to count out the slope. So you're going to go down 1 and over 2, down 1 and over 2. So let's do that. So down 1, over 2, down 1, over 2. We can also go the other way. So you can go up 1, back 2, up 1, back 2. And there is your line. Cutting straight through there. And yes, it is okay for us to do that because we have used these slopes right here. These are opposite reciprocals, so therefore those lines are exactly perpendicular.